Okay, so here I'm going to do an exact equation, and the way that we think about this is, so we have a derivative of some equation, and if we can find the, well, here, let's just rewrite this. We have 2xy squared plus 2y dx, okay, plus 2x squared y plus 2x dy, right, because this is just dy dx is equal to 0. If we can take the derivative of this with respect to y and the derivative of this with respect to x, and they equal the same thing, then what this means is that essentially each of these came from some sort of equation, and we'll just go through this. So we'll think of this side as m, this side is n, so let's go ahead and take the derivative of this. M of x with respect to x is equal to, oh, sorry, I said y, didn't I? It should be y. M with respect to y, the way that I see this is just a dx, and then if it says, if this is the derivative with respect to x, we'll take it with a y here. Okay, so if we're doing this with respect to y, then this becomes 4xy plus 2, which is equal to this one here, because if we take this with respect to x, then it ends up being 4xy plus 2. These are the same, so what this means is that we can in fact use this method. So let's look at our equation up here. Okay, alright, so m, let's integrate m with respect to x. We've got this derivative here, and the way we can look at this is essentially this equation that we're trying to find, psi with respect to x would be equal to this here. Psi with respect to y would be equal to this right here, or, you know, this part right up here. Okay, alright. Okay, so if this is psi with respect to x, then whenever we integrate this, actually we don't even need to write that out like that. Okay, so let's go backwards here. So we get 2x squared over 2y squared plus 2yx plus some sort of function of y. So we're trying to find, you know, where this came from. And so this equation here, if we take it with respect to x, it'll give us this. If we take it with respect to y, it'll give us this. And so what we're doing is essentially we're going backwards with respect to x. If we were to take the derivative of this, anything with the y value would disappear for taking it with respect to x. And so now that we've got this here, x squared, y squared plus 2yx plus some sort of, oh, that's a q, g of y. If we take the derivative of this with respect to y this time, so this is psi, but we don't have all of it, so this is psi, oh, no. So now we want to do psi x, psi of y. And so we've got x squared, 2y plus 2x plus g prime of y. And so whenever we look at this here and we compare it to n is equal to 2x squared y plus 2x, 2x squared y plus 2x. Given that we have this here, and the only difference is that there's nothing here. So if we wanted to integrate this, then we would just get c. So it looks like the actual equation is x squared y squared plus 2yx is equal to c. And I'm going to check it, and that is right. Okay, so that's how we do it.